Thanks. Okay, welcome to the Fukuoka Engineer Cafe. Thank you for coming out to Hack Fukuoka today. Just quick show of hands in the room. Who's the first time they're at Hack Fukuoka today? Who's the first time? Oh, a few people, yeah, some new faces. Brilliant. And some people I've seen at other events as well. Today, we hopefully have a fantastic talk by Andrea Wu from Google in Australia. But I think maybe she's having a little bit of trouble finding the building. So I'm stalling for time today. But even people who've come to this event before, we've got something slightly new. We have subtitles. How are they doing? That's not bad. Yeah. But before our main talk tonight, I thought I would just give a quick introduction for people online who maybe are not in Fukuoka and people who have come here for the first time, and tell them what is Fukuoka Engineer Cafe and what do we do here. So everyone here will have seen this on the way in, but for those of you online, this is the Engineer Cafe. A very famous red brick building here in Fukuoka, but it is more than just a building. It's a community space for engineers of all types in Fukuoka. So we've got hardware engineers, software engineers, beginners, advanced people, all different types. Inside we have this fantastic space where you can study and do group work, have mini events, as well as lots of hardware that we lend out to people. It's not just, can I borrow a keyboard, but it's what key switches would you like? So we have all sorts of hardware here. VR glasses, Sony Mocopi motion trackers, Connect, cabling, anything you could need to do stuff. But even more, downstairs we have a maker space with a 3D printer, a laser cutter, a CNC mill, and various other bits of equipment. So here's some of the kind of things you can make. And all of this is very nicely paid for by Fukuoka City. So we all get to use it for free. Everything. The downstairs, upstairs, all the equipment, it's all free. So if you want to come try it out, you've never been here before, come down to Tenjin and try it out. Awesome. Yeah. Oh, wonderfully timed. So our speaker has arrived. I'm so glad. Don't worry, come in. It was perfect. That was perfect. So, yeah. So basically, we're open to any events. And if you want to do an event, they're run by us, they're run by tech companies, they're run by the community, everything's on the table. It can be super beginner, someone just getting started programming, super niche, if you want to do your sort of 3-person study group for vector programming languages, that's okay. And you can use all our equipment for streaming, our cameras, our lights, soundboards, everything's here. And if you want to give a talk at Hack Fukuoka, this is our English event, feel free to come find me after the event today, or tweet at me, Laurie_LJG, and let's talk about it. But yeah, we want to see all different kinds of talks. Cool. So we're going to just switch over to our main speaker. Do you need a bit of tech setup? That's cool. Okay. Could you just give us a couple of minutes to get things set up? Sorry about that on the stream as well, but I'll be right back. Cool. So yeah, without further ado, going to introduce our speaker for tonight, Andrea Wu from Google Australia, is it?
Google US.
Google US?
Yes.
But you came from Australia?
I came from Vietnam.
Oh, sorry, I was confused. I had it in my head you were coming from Australia. Who came from Australia? My bad, my bad. Okay, sorry about that. I messed up my time zones completely. Anyway, that's my bad. Yeah, and the talk today is all about Firebase and building apps with Firebase in Google Cloud. So I hope some people have experience with it, but maybe some people are completely new to it. So take it away. Thank you.
Thank you. Oops. Yes. Wait. Okay. You're good.
You've got loads of cable now.
Okay, I can. Is that the live stream right there?
Yeah. Well, the whole thing is.
Okay. Does that mean they see my back? No.
Well,
they
the
see
camera's
front.
over there. So
Okay.
if you stand in the middle, I think it works quite well.
Okay. I don't want to block the screen.
You've got loads of cable.
Okay. All right. Hello, everyone. I'm Andrea. As he said before, I'm from the US. Yeah, grew up in California, lived a few years in New York City, and I've been a digital nomad for almost 3 years. So kind of moving around and doing my job through my computer. So today I'm going to be talking about Firebase, which is the product that I work on at Google. So let's say you have a great idea for an app, and you probably start thinking about how you want to build out your app. So this is a pretty common architecture that you're probably thinking of using. So a lot of apps need data, so you need a database. You need somewhere to store images, audio, video maybe, so you have a media server. You need authentication so that you can identify your users and have user accounts. That is your auth server. You obviously have your client-side app, and you have an API server that kind of connects all that together. So this is a pretty standard architecture that you would probably be thinking about for building out your app. And you think about, okay, well, what happens when a lot of users start using my app? Will this still work? Maybe, maybe not, right? So you might start thinking, what about new platforms? What if you start building your app out on web? What about Android and iOS? Is your auth server secure? Is your database fast enough? Can it hold enough data that you need to hold? How do you scale your API server? And is your media server big enough? So these are basically scalability questions that you might be thinking of, because you have a great idea, a lot of people are going to use your app. What happens when your app does get really popular? So with all these concerns, you might forget that the reason you started going down this rabbit hole is because you had a great idea, right? So if only there was some technology that can kind of help you with all those problems. And you probably guessed it, my answer for you here today is Firebase. That's what I'm going to be talking about today. So we ask, what is Firebase? Before I answer that question, how many of you have actually heard of Firebase? Oh, quite a few of you. Okay, that's awesome. So for those of you who don't know or need a refresher, Firebase is Google's client-side app development platform, and it's built on Google Cloud and integrates with a lot of other Google tools, such as analytics and ads. And it's built on Google infrastructure, so it's designed to scale automatically. And regardless of what platform you want to build on, it supports a lot of different client-side platforms. So there's client-side SDKs for iOS, Swift, and Objective-C, Android, Kotlin, and Java, web JavaScript, and TypeScript. And we have support for several frameworks like Angular, React, and Vue, C++, and Unity for game developers, as well as Flutter. And Firebase is a suite of almost 20 different products, and it's intended to help you through the life cycle of developing apps. So as I mentioned before, you have a great idea. First step to do is to build it out. So these products are intended to help you do that. Authentication enables you to know a user's identity and to authenticate them to your app. We have two NoSQL databases, Cloud Firestore and Real-Time Database. There's cloud storage to help you store big blobs of data, like images, videos, and audio. And then there's hosting, which if you're building a web app, helps you put your app onto the internet. So once your app is out there, you built it, yay, you launched it, yay. You probably want to also monitor how it's doing out in the wild, right? So you want to monitor its performance, and you could do that using Crashlytics and performance monitoring. And you can fix bugs and test those bugs on devices that you might not have lying around at home through a test lab. And once this is done, your app will hopefully reach a stable state. And you might be thinking about how to grow your users as well as retain the ones you have already. So these are the products that can help you do that. Cloud messaging and in-app messaging helps you send notifications if you want to remind users about purchases or events or anything else that you want to send reminders for. There's A/B testing for you to test any change before rolling it out to your users. And remote config can help you serve different user experiences based on different user properties, and you don't need to make your users get a new version of your app to have those changes. So all of these products will hopefully help you decide what your users like in hopes of getting them to use it more and also to get more of their friends to use it as well. So as you can see, Firebase has a lot of different products. And the good part of it is you can choose which ones will help you for your app. So you don't have to use all of them at once. And to use any of them, you basically install the Firebase SDK for whatever platform you're using and just pick the ones that you want to use. And for most of these, it's very little code for you to write as the developer. All right, so now that we have an overview of what Firebase is, we'll talk about how to use it to build out a new app. So what are we going to build? We're going to build out an expense tracker. And as a person who really cares about how I spend my money, I have a spreadsheet, and this is not a lie, I really do, to keep track of my expenses. So on my spreadsheet, I'll keep track of the date, the vendor, the items I got, and the amount of money I spent. And this is fine until this happens. I bought a lot of things all at once. I have a lot of expenses, and manually entering all that information is kind of annoying, right? It's not a great experience, and I'm not too thrilled when this happens. So in large quantities, it's not really a good experience, right? So how might we make this problem better? So instead of needing the user to manually input this data, that for receipts that they're probably going to keep anyway so they can manually enter it, we'll make an app to enable users to conveniently scan those receipts, and the app will automatically extract the relevant information for the user to check and then to just put into the app. So this way, the app does all the work of extracting that information so the user doesn't need to manually input it. So this is the app that I'm going to use to frame how Firebase can help build this out. So what are our app requirements? So first, users will be able to upload images either by taking a photo through their camera or choosing a photo that they already have. Then the app needs to be able to find and extract the text. We'll want to scan the receipt to parse for things like the date, the vendor, the item they got, and the amount they spent. And finally, we'll relay what we found back to the user so that they can check the information that we extracted. Well, we need to make sure that the scanning is accurate, because if it's not, they're going to end up manually inputting everything in instead, and that's the problem we're trying to solve in the first place. Right? So we need to make sure that the scanning part is good. All right, so diving deeper into what our app will look like, these are some of the needs. We want to be able to securely upload our receipt images, store these receipt images and extract the text, and do some image processing on those uploaded receipts. Sounds pretty complicated, but let's see how we can do it. So the first thing we said we need is secure image upload, which means we need users to be able to sign in to view their own receipts. Right? I don't really want to spend my time building an authentication system, and it'll probably be quite tricky to get the security and the privacy of it right on the first try. Right? So we need the functionality to work, of course, but on top of that, we need to make sure that people's information doesn't get stolen. Also, as a user of a lot of apps myself, I know that I don't really like creating a new account for every app that I use, right? It's kind of tedious to put in my first name, my last name, my email, my birthday, the street I grew up on, and all that information for every app that I use. And also, I would have to remember another password, which I'm not really good at. Right? So it'd be really nice to not need to create a new account to use this app. So using Firebase Auth, it provides identity as a service, meaning it lets you know who your user is. There's also a rule system that enables you to grant or deny access to a resource in other Firebase products or, like Firestore and storage. Auth also is ready to use out of the box, and it gives some advanced functionalities like email verification and account linking as well. And to address the concern about not wanting to create a new account, Firebase authentication works with a lot of third-party providers, such as Google, Facebook, Twitter, GitHub, and more. And once users sign in with any of these third-party providers, Firebase Auth will give you a unique user ID and a signed web token, which enables you to get a consistent representation of these users, regardless of whether you use Firebase's services in other parts of your app or you have your own servers, right? That unique ID, a user ID, can be used in any system. And this is regardless of how they sign in. All right, so let's see how we can, in code, have a user create an account using email and password, log in with that account information, sign in with a third-party provider in case they don't want to create a new account for your app, and check whether the user is logged in or not. And as a side note, you don't have to worry about copying any of this code down. It's all in the Firebase documentation. So first, let's talk about enabling our users to create accounts via email and password. So to do that, we first have to make some pages for people to input their information. Right? So once they fill this out, they'll click the submit button, and this is what you will do on the code side. So we can call create user with email and password, which will result in either a successful creation of the account or it'll error. And if it errors, you can handle it here. If it succeeds, we'll be able to actually see this user's new account in Firebase console. And this is what it looks like. So Firebase console is a web portal to see what you've been doing with Firebase for your project. And it shows you different things based on what products you're using. So in this case, we'll be able to see the user who just created an account, what provider they used. So in this case, they used email, the date the account was created, and the unique user ID that you can use to identify this user throughout the app. All right, so that's how we would implement code to enable a user to create an account. What if we needed them to sign in with that already created account? Let's say again that this is your login screen. The user types in their information, and they click that submit button. So we'll call sign in with email and password, and again pass in the email and password from the screen before, and this will result in either success or an error. If it fails, we can handle the errors here. Also, all my code is in JavaScript because I'm a web developer, but all of this code is available for other platforms as well, as I mentioned in the beginning. So now let's say our users don't want to create a new account for this app, so we'll enable them to sign in with a provider. And as already shown here on the screen, we need to create an instance of the Google provider object so that it'll enable them to log in with Google sign-in. And if you wanted to use Facebook, Twitter, GitHub, or any of the other third-party providers, you'll basically do this, but give another provider. Next, let's actually make the user authenticate. So there's two ways to do this, either by opening a pop-up window or by redirecting to a sign-in page. So what's shown here is signing in with a pop-up. And we'll pass in that provider into the function call. And what this basically says is use Firebase Auth to sign in with a pop-up using the Google provider. And finally, we'll handle the cases of the user being successfully signed in versus not. So this is the code for implementing authentication using third-party providers. All right, so now we've talked about how a user can create an account, sign in with that account, and sign in with a third-party provider. Now we'll talk about how to check whether a user is already logged in or not. So let's say they come to your app, right? How do you know if they're logged in or not? Whenever create user with email and password and sign in with email and password get called without an error, the on-auth state changed function gets triggered. And if there's a user, then the user is signed in. Otherwise, no user is signed in, and the function got called because the user logged out. So this function will return a user whenever create user with email and password and sign in with email and password get called successfully, as well as with third-party providers, as I mentioned before. And once you have the user, you can also get various information about the user, like their display name, email, their user ID, etc., as shown here. So now we've talked about how users can create accounts and log in, as well as how to know whether a user is logged in or not. One last tidbit, even though the code is already very little, it's quite bit of work to actually create these screens to enable people to log in, right? Sign-in screens with multiple third-party sign-in buttons, or create new user screen, or screens to reset and change passwords. It's a lot of work. And if that's not where you want to spend your development time, there's a library you can use called Firebase UI Library. It's supported for web, Android, iOS. And it's an open source library that provides these pages these pages for you. And because it's open source, you can customize it to the look and feel that you want. So now we've enabled user accounts. The next thing a user will want to do after logging in is probably to upload a receipt or many receipts. Let's say we have a screen to enable the user to upload the receipt, either by taking a photo of it or by choosing a file that already exists. Once they do that and upload it, we need to store it somewhere. What do we want from our storage system? Well, we'd probably like it to be fast for uploading and also for viewing receipts from anywhere. And we want it to work well even with spotty internet connections. We might need to store a lot of receipts, and we might not have a team to keep an eye on usage to adjust the capacity for our storage. Lastly, we might have to consider working with a lot of different image types. So cloud storage was designed with many of these concerns in mind. It lets you store many image types, and on top of that, it lets you store and serve user-generated content like audio and video. It's generally used to store big blobs of unstructured data that you don't need to change too often. To store a lot of receipts, the amount of storage will scale automatically, meaning that storage space will increase as you have more content, and it will decrease as you remove content. So you won't need someone sitting there manually trying to adjust the amount of space that your app is taking. And to be fast from anywhere around the world, cloud storage has a global edge cache, which means that if I just pulled up a receipt to look at it, storage will store that in a nearby cache, so if I wanted to look at the same receipt 5 minutes later, it'll be quite fast. Sometimes internet connection isn't so great. We wouldn't want my receipt to be half uploaded and then dropped because my internet was spotty. So storage takes care of this and handles retrying and resuming my uploads and syncs whenever my phone gets back on internet. After my receipt is uploaded, it can be instantly shared with others. So this means that if my parents want to look at my receipts for whatever reason, they can. On the flip side, we also want to make sure that only people who are we want to be able to access our files are able to. So as I mentioned before, there are security rules tied with Firebase Auth that you can use to guard your assets with storage as well. Cool, so now let's look at some code to actually upload these files into storage. Let's say we have a file we want to upload. Firebase Storage supports files from JavaScript, file, and blob APIs, bytes, and various string types. Where are we going to store it? Storage is structured using folders and subfolders, much like the way our laptops and computers store files. We'll grab the top of that directory structure, which we call the root, and we do that by doing get storage. And we can create a child reference to the full path of the file with the file name. This child reference will be located in the root reference, whether it's a file or a folder. And in this case, we've created a file. So now with our reference, we can then upload it to cloud storage by calling upload bytes, which uploads JavaScript files, blobs, or bytes. We'll pass it the file reference and the information we want to store there, the file itself. The file will then get uploaded, and we can do any post-processing needed after it does so. If we wanted to upload a string, we can use the upload string function and pass in the reference, the string we want to store, as well as what type of string it is. Great, so now we've enabled users to upload receipts, and we'll put those receipts into storage. Next, we'll need to process the receipt and extract the text. But we might not want to do all the processing on the client side, which in this case would probably be a phone. Why don't we want to do that? Well, once we write our top secret code to process those receipts, we don't want anyone to be able to take it along with the data. Requests coming in from users' phones might be trying to steal it, so we need something to help us with running code against our data securely. We want both iOS and Android users to be able to use our app, but we might not want to duplicate code to process those receipts and write it twice. It'd be a lot better if we could write it once and have the code run, instead of writing it once for iOS and deploying to the App Store, and writing it again for Android to deploy to the Play Store. And if you want a web app, you'd have to write it again, right? So if we deploy if we deploy the app separately, iOS users might get this feature first, and Android users might get mad, and we definitely don't want that to happen. And also, lastly, we're looking to process our receipts. We mentioned we'll probably need to run some text recognition on the receipts, which we can imagine might be CPU intensive. The last thing we want is to run highly intensive code off of our users' devices, especially if it might drain the user's battery. So we have cloud functions for Firebase, which essentially enables you to run backend code in the cloud. It's in a secure environment, and you can write this code once for both iOS and Android. And to run the code, you can trigger it based on platform events or HTTP requests on both platforms. And since it's running off of the user's device, it's not going to be hard on their batteries. Best of all, you can basically run backend code without managing any of your servers. So now we know we're going to use cloud functions to run some processing code, but what are our functions actually going to do? What is that processing code going to look like? Well, we need some machine learning probably to help us extract the numbers and information from the receipt. And this is also known as optical character recognition, or OCR. So we want to get this automatically done, but I don't really know how to do machine learning. Machine learning is not a trivial task, and usually a team will need a data scientist or a machine learning expert to build and train these models. And in order to serve these models dynamically, we'd have to build up the infrastructure to do that. And that's all even before we write the client code to interact with the model and make actual predictions. So this sounds like a really involved and long task, and it usually is, which we might not want to do ourselves. So instead of building out our own models, we can use Firebase machine learning to help us. So what is it? It uses some of Google's machine learning models to help with different machine learning capabilities, depending on what features you're looking to add to your app. So it can recognize text or barcodes from an image, translate text to a different language, or identify important objects in a photo. No machine learning experience is needed. You can just call these Google Cloud Vision natural language APIs in your app, and you're pretty much ready to go. While those libraries can be useful in many situations, what if you have machine learning needs that don't fall into one of those categories? Firebase machine learning has custom model serving and AutoML Vision Edge that enables you to create and deploy custom machine learning solutions on your users' devices as well. So to do OCR, we're going to use text recognition. So now we've used some machine learning to extract text from the uploaded receipts. What do we do next? After we get that text back, we need to put it somewhere in a secure environment. There's probably going to be a lot of extracted text, and we want this text to be quickly accessed from anywhere in the world. Where should we put it? Cloud Firestore is probably a good option. As a reminder, earlier we talked about storage, which we use to store the receipt images. So storage is usually used to store big chunks of data like images, audio, and video. Cloud Firestore, on the other hand, is a NoSQL database where you can store data like strings, numbers, and whatever your app requires. Firestore is used more for structured data that might be changing often. So while our receipt images are stored in cloud storage, the processed text that we get back from Firebase machine learning will be stored in Cloud Firestore. Very similar to storage, Firestore has security rules, so clients can talk to the database directly, but you can still make sure that they only get access to documents that they're supposed to be able to see or modify. So let's dive a bit deeper on how Cloud Firestore is structured and how to use it. It's a document model database, which means that all of your data is stored in documents and collections. You can think of a document as something like a dictionary or a hash table. It has a set of key value pairs, which we refer to as fields, and the values here can be a number of different types, anything from strings to numbers to binary values to JSON looking objects that we call maps. So here we have the document containing the fields we saw on the previous slide. Each of these documents is stored in a collection. And documents cannot contain other documents, but they can point to collections that contain other documents, which then can point to sub-collections, and so on. So in our example, each document will contain information from one uploaded receipt. Here are some examples of what that might look like. Each receipt document contains some values, including the user as identified by their user ID, the date, the amount, the vendor, the item, and whether the user has verified this information yet. All of these will go into one collection, a collection containing all of our receipts. So with code, it'll look like this. First, we'll add a document using add doc, and the first argument is which collection we're going to put that document. We're going to put it in a collection named receipts. What are we adding to each document in the collection? Well, we want to add the key value pairs that we see in this receipt on the right. We'll also want to say whose receipt it is, and we'll do that by using the user ID provided by Firebase auth. When the document is successfully added, we can do whatever we need to do. And if there's an error, we can handle that here as well. And in Firebase console, this is what it looks like for Firestore. As you can see, here's the receipts collection. And the document name is a random string made up by Firestore. I didn't type that in anywhere. And that automatically happens when we call it add doc. Inside of this document, you can see all the fields we put in when we called add doc. So now we've added the extracted text for our expense tracking app into the database. But how do we get that data out of the database in order to send to the user to help them verify all this information? Since we want to get not all of the receipts that exist in the collection, but only want that specific user's receipts, we'll write a query to do that. We'll use Firestore's query function with the first argument saying where to look. In this case, we'll want to look in the receipts collection. The other arguments for the query function will be our queries, and we can use where, which takes a field to filter on, a comparison operator, and a value. So in our case, we want to get all of the receipts where the user ID equals the function's UID parameter. We also only want to get the documents that the user hasn't verified because we don't need to give them ones that they have. So we'll have another query where we check for that. So with that query, we can use the getDocs function to get all the documents that satisfy this query from the receipts collection. With what we get back, we can then loop through each of the documents and send the information to the user to verify. As a side note, in Firebase, we actually have two database products. One is called Firestore, which we just talked about, and the other one is Real-Time Database, which is the older database product. The major differences between these two is that Cloud Firestore is faster at reading and has better querying capabilities, and Real-Time Database is faster at writing. And the reason for these differences is how data is stored in each one. So Cloud Firestore, as I mentioned before, is using collections and documents, whereas Real-Time Database stores it as a giant JSON tree. If you want to find out more about their differences and help you figure out which one to use, there's a link to a doc specifically talking about that. Now that we've extracted text by deploying functions that runs our text recognition and machine learning, and finally stores that into Firestore, what comes next? We want to notify our users that we have their values, and we'll ask them to confirm it. How do we do that? Let's send a push notification by using Firebase Cloud Messaging to tell users to confirm their receipts. Firebase Cloud Messaging is a cross-platform messaging solution that lets you reliably send messages at no cost, and it can deliver hundreds of billions of messages per day. And they're delivered usually in less than 200 milliseconds, so quite fast. Our users trying to upload receipts probably all use different types of devices. Thankfully, we don't have to invent our own notification system for each phone or each device because cloud messaging can deliver notifications to anyone using Android, iOS, or the web. Cloud messaging doesn't need us to track what kind of devices our users are using, and we also don't need to set up different service calls to different devices. Firebase Cloud Messaging will automatically do all of this for you. Lastly, we're not only limited to using this to remind users to confirm their receipt amounts. We can also announce new features we're launching. For apps that isn't this expense tracker we're talking about today, we can notify users for things like letting them know their last message was responded to, sending out discount offers, and reminders about events. So now we have notified our user to confirm their receipt amount. we'll store this response back into Firestore. Now that we've built out our app, it's just sitting on our laptop or maybe somewhere in GitHub. If we build this using mobile, like Android or iOS, which is probably the most likely chosen platform for this type of app, we'll eventually have to figure out how to put it on the Play Store or the App Store. If we built this on web, however, we can use Firebase hosting to help us get it off our laptop and actually deploy it onto a website for people to use. So let's talk a bit about Firebase hosting. First and foremost, it's a pretty straightforward way to host your web apps. All you really need to do is install the Firebase command line tool and write a single command, Firebase deploy. And if for any case you want to roll back your app, you can go to Firebase console and roll back from there with just one click of a button. And it really is this easy, I'm not exaggerating. Firebase hosting has a global CDN, and this means that there's a distributed set of servers holding your content all around the world, so that whenever someone pulls up your page, the content is retrieved from a location as close to them as possible, making their experience quite fast. Sometimes we'll have to update our website after deploying it once, because maybe there's a bug, we added some features, or some other reason. When we do this update and redeploy to Firebase hosting, it's atomic, meaning that all of the servers get updated with that new content and all the caches get purged. So this way, the user is guaranteed to get the latest version, and you also know exactly what they're getting. So there we have it, our app is built. We've successfully built an app from beginning to end with full functionality. We've enabled our users to log in via authentication, upload receipt images, which get stored in storage, trigger functions to do OCR using Firebase machine learning to extract details from the receipts, which then get put into our Cloud Firestore database. Next, we ran some more functions based on values being written to Firestore to automatically send a cloud message to a user to have them confirm their receipt amount. We even then put it up on a website so people can start using it. For all of this functionality, we didn't have to write a lot of code. All the code I showed you today is really all you have to write, right? So these are pretty much all of the Firebase products that can help you build an app. And actually, usually we consider cloud messaging to help you grow your app, so I kind of tossed that in. All right. So here are some resources for all the materials I covered today. The first one is a link to our Firebase website, and there you can see an overview of all of our products in detail. Each product also has a lot of documentation and guides you through that particular product. And as I mentioned before, all the code I showed you today is probably somewhere on those docs. The second link here is our official YouTube channel, where we show and step you through different Firebase use cases and help you with specific products. I've actually made a series building out a web expense tracker, going through all of these products in deep detail. And there's code for you to follow along as well, if you wanted to check that out. Lastly, you can always use your favorite, the last link on here is our blog, which again, helps you step through different Firebase use cases and deep dives into specific products. And lastly, you can always use your favorite search engine to find more information about Firebase, as it's a pretty well-supported community. So that's all I have for you today. Thank you all for coming, and I'm happy to take questions.
Awesome, thank you very much. So we do have some food on the way, but we've got a bit of time for questions now. So anyone got a question? Let me pass these mics around.
What's the local development experience like? So if you wanted to develop code and debug code without being online all the time?
Yeah, so we have, I've been meaning to add this to this slide deck, but we have something called Firebase Emulator. It's supported by a lot of our different products, and it basically gives you an environment to test in, so you don't have to put this in prod.
Yeah, can I answer that question as well? Because literally my latest work has been setting up Firebase emulators for a project, and yeah, they're further along than they were a while ago, right? Yeah. They used to be a little bit, difficult, but now they're much more mature. So it's worth giving it a try. You can test locally and have your CI/CD stuff set up as well.
Hi, thank you for the presentation. There is a big concern now globally about the data and privacy. and it's not only in Amazon, also in Google and
Sure.
many. So how in that Firebase, how they are approaching to provide to customer, to ensure that it's our data information is secure and it's not could be used for other purpose.
Yeah, so as the developer, as I mentioned, there's security rules, right? So you can make sure that users are only getting the information that they should be getting. So that's how you can protect your users. As for how Google does it, or protects your users' data, right? That's probably what you're asking. I'm not an expert on this, so I don't actually know, but I'm sure, we try our best, right? We're not trying to intentionally leak your data out, right?
Is the question?
Go on, do you want to jump in? Oh. Get me quick.
I'm really honored to hear this presentation because I created this the engineer cafes, the managing the user system. The backend is Firebase.
Oh,
and
awesome!
yeah.
That's great to hear.
But I really like Firebase, but I'm thinking about change to the Superbase.
Okay.
Because it's so hard to implement the search functions.
Okay.
Yeah, because I think
With Firestore.
yeah, Firestore
Yeah.
is so hard to
Yeah.
search the users. So
Yeah.
is there any solutions about the kind of search?
Yeah, so
functions, things?
we are working on that. So Count recently came out, and I think OR was recently announced as well. So hopefully that makes it a little bit easier. We got this feedback a lot, so we are working on it. I think there is a Firebase extension. Let me see if I can find it. Let me do it on my own screen here. Okay, here. Or I can do it on. Well, I can't see that screen, but let me find it. There is, I think, one Firebase extension that lets you do that. Yes, this one. I can get it to work. Yeah, so this one enables full text search of your Cloud Firestore data.
Yeah, I know.
Okay.
I know this, but
Okay.
it's
Doesn't work very well.
no. I think it's have to pay
Oh,
the
okay,
fee,
I
right?
see.
So
Okay.
is it possible to do as a free? Is it hard?
Well, I don't think
So-
I'm not I'm not the one making those types of decisions, but
You should get Fukuoka City to pay for it.
Thank you so much.
yeah, of course. I'll take that feedback back to the team. Yeah, I'm also happy to hear any feedback. That's kind of part of my job. Also, another reason why I do this, if you're already using Firebase and you have product feedback, I'm happy to take it. Like, don't be shy about giving us feedback. That's what we're here for.
I think there's a question over there.
Yeah.
Hello.
Hello.
So my company, Steampunk Digital, we do a lot of 3D reconstruction stuff. We use Firebase for our whole Monaco Cloud backend system. But one of the challenges we have had is what's a good backup solution? We've kind of rolled our own, but I'm just wondering what Firebase, for backing up a Firestore database and our storage and our accounts, all the user accounts.
Okay.
How do we make it so in case of an emergency, something melts down or someone hacks our system and blows up all our data? How do we just take a snapshot or do something like that?
I don't believe you can for auth. I think you can for Firestore, but I don't quite remember. I think there is a button inside of Firestore to let you do that, I think. It's either real-time database that enables you to do that, or it's Cloud Firestore, I don't remember which one. And with storage, I don't think there's a way to do that either. That's a good question. I think my team is still asleep, so I won't be able to ping them, but I will try to get an answer to that and get it back to you. Yeah, I'm gonna write that down, hold on.
Grab a mic. Can we jump at the back first and then you're next? Okay. Juggle it across. Well, if you got the mic, you go first. We haven't forgotten you.
Yeah. Yeah, thanks for the presentation.
Yeah.
So you mentioned like file storage has various edge locations,
Yes.
but what about other services like cloud store or authentication? Do they have like, do they replicate data across different data centers or something?
So actually for storage and Firestore, when you create your assets, you'll actually choose a location for where you want it to be located. So it'll be, yeah, you'll choose. Authentication, I don't know, you don't get to choose. So I want to say I don't know where those servers are. Yeah.
Okay, got it. Thank you.
Hi, yeah, thanks for coming to Fukuoka.
Yeah.
I'm learning about like SQL and NoSQL databases.
Yeah.
And I want to try to make a project with both types of databases and kind of like race them to see the pros and cons of them.
Okay.
It sounds that the databases you talked about with Firebase, they're both NoSQL databases.
Correct.
So what if I want to use like a SQL database? Do I have to use like some kind of like a different company
Yes.
with the other Firebase like products?
Yes. Yeah, we don't have any SQL databases at the moment. Yeah.
Okay. Yeah, thanks.
No worries.
Any other questions? Comments, feedback for Firebase? If not, then let's have another round of applause. A big thank you for coming to Fukuoka and the Engineer Cafe. So this is going to be the end of the stream, but everyone here, we're going to stay, hang out a bit, chat about all the cool tech stuff we've been doing. There's some food coming. It's supposed to be in about 10 minutes, so we'll see. But yeah, we can all just kind of hang out for another couple of hours, do whatever. Thank you very much.